Welcome to Secret Squared. I'm Cassie Secret. I'm Megan Secret, and today we're going to continue our series on exponent rules, and we're going to cover the power rule today. So let's dive in. Now, as we talk about power rule today, it's important to know when we're going to use that rule. Now, we're going to use that rule when we have a term that is already raised to a power, and if that itself is then being raised to another power, that's when we're going to want to use power rule. So for instance, in our last video when we talked about the product rule, we used the product rule when we had the product or we were multiplying like two terms that had exponents. In this case, it's the power rule because we have some term that's raised to a power has another power. Now, that might sound confusing, so what that could look like. That could look like something like if we have x to the power of 3, we're going to count that as the term raised to a power. We have the x and has the power or the exponent of the 3. Now, if that itself is being taken and is being raised to the power of 2, this is a great example of when we would have to use the power rule because we have something being raised to a power and that is being raised to another power. And it doesn't, when we say raised to another power, this could be a 3, it could be the same as the power that was already there, doesn't really matter. It could be any number as long as it's that exponent. So for another example, now when we're actually going to work one out, like our other videos, when we're talking about all of these different exponent rules, it's really important to understand the why of these rules instead of just memorizing them. So to start, we're going to show you like the mechanics behind it, and then we'll show you the rule officially. So let's say you had the term 3x squared, and that's being raised to the 4th power. If you know the product, not the product, if you know the power rule, you have a little bit of shortcuts. If you don't know necessarily the power rule, we at least know that anything to the 4th power means we have the term, and that is being raised to the 4th. We have this term being multiplied to itself 4 times. So we have 3x squared times 3x squared, and we have 4 of them all being multiplied together. And the reason that's happening, we had mentioned in a prior video, remember, exponents are really telling you how many times you're multiplying something. So that exponent of 4 says that we're going to multiply what's inside the parentheses 4 times, which is why we wrote it 4 times. And then from here, without any of the exponent rules, you could say, okay, we have 3 times 3 times 3 times 3. That ends up giving you an 81. So we have an 81 in our final answer. And then from there, when we're dealing with all the x's, remember, we just want to see how many x's are being multiplied. X squared, we're multiplying 2 x's, now we have another 2, so there's 4 of them. 2 more, now there's 6. 2 more of them, now there's 8 of them. So we're going to have x to the power of 8. Now, if you're already familiar with the product rule or saw our prior video, this is going to look very familiar. Pretty much what we're doing is we're taking something that's written with that exponent on the outside, and we're writing it so we can use it with the much more familiar product rule. And a different example that's a little bit harder, we have maybe negative 2ab squared, also 3rd power. Still not using the power rule yet. We can use the fact of that exponent of 3 means that we have this term 3 times and those are all being multiplied together. So we can rewrite, there we go, we can rewrite all that out. So we have negative 2ab squared times another negative 2ab squared times another negative 2ab squared. This one is definitely going to be a little bit messier because of the negatives. So what you can do is just start with, we have 2 times 2 times 2. So we do have an 8. Then we can deal with the negatives. One negative times another negative gives you a positive. So these two terms multiplied together are positive. That multiplied by a negative will give you a negative. So really all of those negative 2's multiplied together give you a negative 8. And then from there you want to deal with those variables. Deal with it one letter at a time. Now, for the a's, I don't have an exponent, so you have that invisible exponent of 1 that we're going to write. So I have 1, 2, 3 a's that are being multiplied, so that's a to the power of 3. And then you do that same thing with the b, which already has its exponents labeled. So I have 2 b's, another 2 b's, another 2 b's. So if you're familiar with product rule, you're going to add those exponents, and 2 plus 2 plus 2 will get you b to the power of 6. Now, that's going to be our final finished answer for these two. As of now, again, we have not shown you what power rule is, but we're showing you how you can make sense of it. In this next part, we're going to see exactly what the power rule is and how we can use it as a little bit of a shortcut. So before we write down specifically what the power rule is, we jotted this off to the side. This is the question and the answer for on the last page, that last question. We're going to use that as an example of how the power rule really works. So looking at it, and it's going to be the easiest to look at just the b variable. We have a b squared in that term, and that extra exponent is a 3. So it has exponent 2 and that extra exponent of 3. Now, even if we weren't trying to break it down and explain it like we did on the last page, if you were given this and the answer, you would notice that the 2 and the 3, and there's a 6. And if you were to take 2 and multiply it with 3, it would actually give you 6. Now, that is actually what's happening in this case. Okay. And even though it doesn't necessarily look like that is the rule that holds for the -2 and the a, for the a, it doesn't have an exponent, so really it has a 1. And then when you take that exponent 1 times 3, it does give you that a cubed. And for the number, that I think tends to be the one that throws people off the most. You have that -2 in front. Now, it does not have an exponent that we can see, so we can write that invisible exponent of 1. And from there, the rule is you're going to take the exponents and multiply them. Now, 1 times 3, that would get you -2 to the power of 3. And what that actually means is you're just going to take -2 and multiply it 3 times, which is exactly what we did on the last page. And that -2 times -2 times -2. And that does give you the -8 that we have up there. So what our rule really is if you're having something, we're going to call like x to the a, where a could be any number. And if that's being raised to some power b, again, b is just like a stand-in for any number, what you're going to do is take those exponents a and b, and you're going to multiply them. One trick that I like to kind of use to remember this is you see the parenthesis between the a and the b. And a lot of times when we see parentheses, we're thinking about multiplication. If that's something that helps you to remember, that's fantastic. If not, I know some people will just start to remember on their own. So now using that power rule, and if you like how on the last page it was fully written out, you can definitely use that. Sometimes the power rule is just helpful because maybe the exponent is like 5 or 6 and it's a bit bigger number and you don't want to fully write it all out. Power rule helps just simplify some things. So for example, let's say we have 3x, y to the 4th, all of that is being squared. You could write all this out twice and multiply it together. And actually for that one, it wouldn't be that bad. Yeah, it'd probably be maybe not the easiest, but it's just a 2, yeah. So it's not too bad. Exactly, but we want to make sure we're showing you how you can actually use the rule. So to start, it's really helpful to make sure that everything has an exponent that you can see. So that 3 gets an exponent of 1, and the x also gets an exponent of 1. From there, once everything has an exponent, you just want to make sure that those exponents get multiplied with the exponent on the outside. So we have 1 times the 2 gives you a 2. So we end up with having 3 now to the second power instead of the first. Similar idea, the x to the first, that 1 times the 2, that 1 times the 2 gives you a 2. So we also have x squared. And then for the last one, we have y to the 4th. Because the exponent has 4, we will do 4 times 2, and that gives you 8. Something important to note is definitely for the 3 and the x, it does just look like we're giving the 3 and the x, the exponent on the outside, that 2. Technically, we are still multiplying that 1 with the 2. It's just because 1 times 2 is still 2. It looks like we just give it that exponent. Yeah, so just make sure you want to constantly remind yourself that we're not just taking that 2 and shoving it into those slots. We are multiplying with all the exponents. Something else I also want to make sure I note, because a common issue people will do, right here, we have 3 to the power of 2. That 3 to the power of 2 is 3 times 3. Now, that ends up giving you 9. Do not. A big thing, people see the 3 and the 2, and we really want to multiply it and say 6. We just have to remember the exponent means how many 3s we have. Almost all the time when we see mistakes, the mistake tends to be people take the 2, they forget to write that exponent, and they say, oh, the 2 is going to the 3. I'm going to do 3 times 2. And they multiply. And they put a 6 in front. It's not a 6. So just be careful of that. And then the rest of it, actually that x squared and that y to the 8 is just going to go ahead and stay the same. So we ended up being able to actually simplify this little chunk because we know what 3 times 3 is. We don't know what x times x is, and we don't know what y to the 8th is. But if there's any number with an exponent, we typically simplify that as much as we can. And that is our final answer. Now, for our last example, we went ahead and we put that power rule up in the corner that we can use it to reference. And this example is a little bit different from the last one. We still have 2 variables, but we do have a negative in there, which can tend to throw a lot of people. Now, we purposely picked this example with the negative because it tends to be something that throws people off. So first thing we want to do, when we have that exponent on the outside, we're going to have to multiply it with the exponents on the inside. So anything that is missing an exponent, that b doesn't have an exponent, we want to add it. And there's not really a coefficient or number in the front. There is a negative, but it's really a -1 that's being multiplied. So we're going to put that -1 and give it the exponent of 1 just to make it super clear what number we are working with. Yes, so be super careful. It does actually have that 1 in front. So from here, now that all of this is written out, now we can use our power rule that's going to tell us that we need to multiply the exponents. So we're going to end up just starting like left to right. We're going to have that -1, but that -1, we have the exponent of 1, exponent of 3 multiplied together, it gives us a 3. And this is the big place where people run into issues with the negatives. Some people write it like this. Some people will write it like this, with the parentheses. Now, they're actually, I know a lot of people will see it and think that they're the same. They actually are not the same thing. The number that we are multiplying here, we have a -1. That negative goes with the 1. So in this case, we actually have to have it written as the parenthesis -1, that the entire -1 gets the exponent of the 3. In this case, only the positive one gets the exponent, the negative doesn't. I will say technically, both of these will give you the same answer, but that is not always going to happen. That is luck. Complete luck. The parentheses do have to be there. So in this case, we are going to strike that out. We don't want to use that. We want to use that -1 in the parentheses, so the entire -1 gets the exponent. Exactly. So honestly, when in doubt, you can always use those parentheses. It is really important. Or when in doubt, you could write this one out like we did early in the video as -8⁴ b and write it 3 times with the exponent. Now, again, either way, whatever makes the most sense to you. So from there, we have -1. It's going to have the power of 3. A to the power of 4, take that exponent of 4, multiply it with the exponent of 3. That'll be a to the power of 12. And then for the last one, the b has the exponent of 1. That 1 times 3 gives you 3 still. And then from there, a lot of times the last step you'll have is to be taking whatever the coefficient was and raising it to that power. Be really careful with -1 to the power of 3. You are taking this, and this is really -1 times -1 times -1, which that is not -3. A lot of times people will just say, oh, it's -1 times 3, but that's not it. So we want to be really careful, and if this helps to fully write it out, you have -1 times -1 times another -1. This first little chunk, negative times a negative, gives you a +1. And then we still have times that -1. And then once you get to 1 times -1, you end up with just a -1. So really we're going to end up with the coefficient of the -1 at the very front. Now, another thing that you could use if negatives tend to throw you off, if you were just doing 1 to the power of 3, 1 to the power of 3 is just 1. And when it comes to that negative, the big issue is, do I keep the negative or does it become positive? If your exponent is odd, the negative is actually going to stay. If the exponent is even, then the number is going to turn positive. So you could use that as well to check your work. And then everything else is just going to tag on. Because again, we don't know what a to the 12th is, we don't know what b to the 3rd is, but we can deal with that coefficient or the number in the front. Yes. Now, I know some people will like to write it without the 1. Some people will like to write it -a to the 12th, b to the power of 3. Either one, they mean the same thing. It's probably a little bit simpler for the bottom one, just that there's not the number there, but that's personal preference. Thanks for watching! If you enjoyed this video, please like and subscribe. If you have any other topics you want us to cover in later videos, leave us a comment below. We'll see you next time!